going to do is take what we've learned about the theorems and the converses, which are listed here, and we are going to take those and apply them in proofs with all the other things that we learned in the other chapter, chapter 2. So the very first thing we notice is they took the given and they put it in the first step, which they always do, and they took the prove and they put it in the bottom step. So my question to you before you even start the proof is, do you know that you have parallel lines? And the answer is yes, because I gave them to you. So that means you are free to use anybody on this side of your chart. Second question, am I trying to show that parallel lines are there? Am I trying to prove lines are parallel? And the answer is yes to that also. So guess what? You still are going to be using the converses also. So you're going to be using some from this side and some from this side. You have to know when to use what. So let me show you how to do that. So the first step is P is parallel to Q. So you're going to go up to your picture and you're going to put arrows on P and Q. So add your arrows to show they're parallel. And then we're going to mark angle 4 is congruent to angle 1. So we're going to put an arc mark on 4 and an arc mark on 1. Step 2. They want to know why 1 is congruent to 3. So you go up to your picture and you look at angles 1 and 3. So I'm just going to kind of color in angles 1 and 3. And you have to ask yourself, what logical reason would they have to say that 1 could be congruent to 3 if P is parallel to Q? So I go over to my reference sheet and I look at all these reasons because the parallel lines are going to cause those angles to match. And I notice that 1 and 3 are corresponding. And I say, oh, well, the corresponding angle postulate tells me if my lines are parallel, then corresponding angles are congruent. So I'm going to call this CA postulate. I'm using a postulate like a theorem because I know my lines are parallel. Okay, step 3. 4 is congruent to 3. So you look up at your picture, and some people might think that you could use AIAs, but remember, I did not give you N is parallel to M. So if I didn't give you N is parallel to M, then you can't use the alternate interior angle theorem. It wouldn't work because your lines aren't parallel. So you've got to come up with a different way to get this step. So what I want you to do is go to the old school idea that we used last chapter and look at these two steps 1 and 2. And you're going to notice that the 1s match. So we're going to ditch the 1s and we're going to put 4 in place of 3. We call that substitution. For all of you transitive people, you could call that transitive if you like that. I've been using substitution. Okay, now from 3 to 4, these angles we now know match. So I'm going to go up to my picture and I'm going to color in 4, the same color as 3. Now I know 3 and 4 match. It says right here. So if those angles match, why would they make my lines N and M parallel? So let's go up and see. If these angles match and they're alternate interior, they're going to force my lines to be parallel. Why? Well, that's going to be a reason from this side. So we know that they're alternate interior, and they're going to make my other lines parallel. So I'm going to use the AIA converse. So the last step will be AIA converse. So the hardest part of these proofs is deciding, are you using a theorem, which is a postulate or theorem, or are you using a converse? So that's kind of how they run, okay? So we're going to look at another example. The more you see, the better off you're going to be. So we're going to skip down. You guys are going to skip the second one. We're going to go down to the third one. And we're going to write the given in, P parallel to Q, angle 2 congruent to angle 5. We're going to go to our picture, and we are going to put arrows on P and Q. And I'm even going to highlight P and Q so that you know those are the only ones that I know are parallel. And then I'm going to go down to the prove, and I'm going to put N is parallel to M because that's who I'm trying to get parallel at the end. Okay, now before I start the proof, I already know that I'm going to be using a theorem or postulate from the left side because I was given parallel lines. But I also know that I'm trying to prove lines are parallel, so I know at the end of the proof I'm going to be using a converse to show that lines are parallel. So I'm going to be using one from each side at least. Okay, so let's go to step 2. They would like us to use the AIA theorem from the left side. So the AIA theorem over here says if you have parallel lines, which we do, then you've got to go find a set of AIAs that will be congruent. Okay, so I have a question for you, and I want you to consider which pair would work. So I'm going to write this in pencil, and then you guys are going to tell me which pair you think would work. So I have a couple different AIAs. I have angle 2 could be congruent to angle 3, and I also have angle 3 congruent to angle 4. Those are my AIAs. So one of these pairs is right and one of these pairs is wrong. And that's because the only parallels I know are the yellow ones. So I need to ditch the pair that don't have to do with the yellow parallels. So the pair that you have to use are 2 and 3. So if you picked that pair, congrats, because that's right. This 3 and this 4 is not allowed. And kids use that all the time, but you cannot do that because you don't know that n is parallel to m. So only 2 and 3 are allowed. Okay, next, they would like us to use substitution. What do? Well, we go up and we look at the 2 steps that we already have, and we look at who we can ditch or get rid of. So we're going to get rid of the 2's, and we're going to have angle 5 is congruent to angle 3, or angle 3 is congruent to angle 5. It doesn't matter which order you put them in. For the 4th step, we are trying to make lines parallel. That means we need to go pick a converse. So how do we know which one to use? Well, go up to the step right above. You like tilt your head just up a little bit, and you look at the angles that are right above that last step, and you ask yourself, what kind of angles were 5 and 3, and why would they make my other lines parallel? So go to your picture, and let's look at 5 and 3. So 5 and 3 are known as corresponding angles, and if those corresponding angles match each other, then that's going to make line N parallel to line M. And so I'm going to go to my cheat sheet and I'm going to look. I'm trying to prove lines parallel, so I'm going to choose the corresponding angle converse. And that's what will go in the last step that makes my lines parallel. So CA converse. Okay? All right, we're going to do one more, and that's going to be the very last one on the packet, and then you'll go back and try the other 2. Okay, this one's a little bit longer, but don't be nervous. We'll go through it together. You're going to put the given in. Oh, it's already there. Okay, let's put the prove in. Angle 1 and angle 3 are supplementary. So, do I have parallel lines in the given? Yes. So I know I'm going to be using a theorem or a postulate. Do I have parallel lines at the end of the proof? No. So guess what? My guess right now is I will not be using a converse. I already know because I'm not trying to make lines parallel. So the converses are off limits for this proof. All right, so let's start. First step. They would like you to use the CIA theorem, and they've already marked with arrows. That was really kind of them. They put arrows to show that they're parallel. Okay, so the CIA theorem. Well, let's go back to look at what the CIA theorem says. If 2 parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. And even if you look at a picture, you can tell. So if they're supplementary, then I need to say angle 1 and angle 2 are supplementary. Keep in mind that the CIA theorem said they were supplementary. It does not say they're adding to 180, and it doesn't say they're congruent. Okay? Now they would like you to use the definition of supplementary angles. Oh, this should feel familiar from last chapter. If I know angles are supplementary, then the measure of angle 1 plus the measure of angle 2 will add up to 180. They're going to be summing up to 180. Next, they would like us to use VAC, or the vertical angle theorem. Vertical angles are congruent. So go to your picture and look for the vertical angles. And since it says congruent, you have to say congruent. So you're going to say angle 2 is congruent to angle 3. Since that says congruent, we have to say congruent there. Step 5, old news, definition of congruence. We used this last chapter. If angles are congruent, then their measures will also be equal to each other. So we change both to the measure of angle 2 and the measure of angle 3 and put an equal sign. Next, they would like us to substitute. Okay, so to substitute, we're going to look at steps 5 and 3. And we're going to make a substitution in for one of these. Well, I'm going to tell you right now, 2 matches 3. So if 2 matches 3, then I'm going to go up and get rid of that dude, 2, and I'm going to put 3 in his place. So we're going to knock out 2, and we're going to put 3 in its place. So it's going to be reading The measure of angle 1 plus the measure of angle 3 equals 180. And we're going to finish the proof by calling 1 and 3 supplementary. So if 1 plus 3 add to 180, then I am allowed to call them supplementary. And so what I'm going to do is call that the definition of supplementary angles, but you're using it backwards, which makes it feel like a converse. That's because definitions are biconditionals. You can use them backwards. And you might look up here and notice that this is kind of a proof of garbage angles. These are garbage angles, and it's proving that they're supplementary, which happens every time. So that's a proof of what happens to garbage angles when you have them. Notice we did not use a converse, and that's because we were not making any lines parallel, so these were not used in this proof.